Welcome to lesson 85, graphing piecewise functions. And this is one that used to give me a lot of trouble as a kid because it almost looked like a hodgepodge, like different pieces of different equations coming together. And it wasn't like a pretty, it didn't have a pattern to it, didn't look complete, it looked weird to me. And so I think because it looked so weird, I didn't like doing them, they were hard to draw. But I want to get over that fear, and I want to show you how I can just chunk through to help graph and show you how to graph a piecewise function. Here's our criteria for success. We want to make sure that you can show that you can interpret those inequality symbols. So knowing whether it's going to be a closed circle or an open circle at certain points. And we're going to use annotations to identify the starting point of each function. And finally, we're going to correctly graph each function. So this is a push. I'm so uncomfortable doing this as a kid, but we're going to get over it and learn how to graph these together because we can do this. So what we're seeing is we're going to have two different pieces here. We're going to have one function, which is -1/2 x, and then we have another function, which is just x. But what's true is this function here is only for when x is less than 2. So I'm going to, in a really light line, I'm going to kind of, so here's where x is equal to 2. Okay, that's x is 2. And that means everything less than that is going to be this part, -1/2 x. And everything when x is greater than 2 to the right, everything on this side is where I'm going to graph just x, where f is equal to x. Okay, so let's see what this looks like, and let's just try it out. I'm going to try just graphing f of x when f, like if I just did this, f of x is equal to x, then I would know that the slope is just 1. It would look like this. It would just be a straight line. Okay, nice and easy, slope of 1, nothing's really happening, no shift, is starting at 0, 0. The challenge is that I know that it has to be where it is greater than or equal to 2. So at this 2, I'm going to have a closed line. And everything else before it doesn't exist. Like I'm not looking at it. So I'm just doing that piece over there. Now the other equation is -1/2 x. All right, -1/2 x. So I definitely know that 0 is going to be the intercept. I'm going to do this one here. Actually, I want to use both. So I know when x is 0, y is equal to 0. And I know that the slope is negative and it's -1/2. So down 1/2. So this is what my slope is going to look like. Oops. Made a little error there. Okay, so this line is going to look like this. Okay, so this is my piecewise function. Now the one thing to remember is that for this one over here, f of x is equal to -1/2 x. It is when x is less than 2, so this has to be an open circle over here. So it will not touch at that 2. That's not going to happen. Whereas for our other one, x is greater or equal to 2, so it can be in there. So it's that closed point. So I want to make sure that is really clear. But that's what the piecewise function is. It's like pieces, little intervals. So we're showing like from this interval, this is this graph, and then starting here is a whole new graph, a new function being graphed. It's just interval pieces. So hit pause and just jot this down into your notes. So we're going to do one more. If you would like to hit pause and try this on your own, you can. I'm going to actually graph this and continue getting comfortable being uncomfortable. And here we have two different functions. F is equal to the absolute value of x, and we just have 4. So how do we graph these two? I'm going to start with the f of x one first, and we do have an set of intervals here. So we know we're going from -3. So from here to here, we're graphing that part. So just that area happening in here. But I'm going to start by just graphing the entire part. And this is just absolute value, so I know that it looks like this. It's that perfect V. Ah, there we go. Okay, and we know we're looking for where x is absolutely equal to -3. So at that point over there, and when x is less than 1. So I'm going to open this up over here. Okay, so because that's true, I'm going to erase the rest. Okay, because I literally just want this to be true. Okay, and then for the other part, I'm going to do this one in blue, when f of x is equal to 4. So 1, 2, 3, 4. That's just going to be a vertical line this way. But let's look at the intervals I want. I want when x is equal to +1. So I'm going to put that there. And to +2. So this one's super tiny and short. So that's all I'm looking for there. And that's it. There's my notation. I've graphed the functions. So those are things we're looking for. One, it being able to interpret those symbols. And you saw how I was doing that to figure out the intervals. And I was helping to figure out if these are going to be closed or open circles. And you can see that here in this one. I knew this one was going to be closed and this part was going to be open. And the second thing is just using those annotations to figure out where it was going to start and where it was going to end. And then finally, just being able to correctly graph these. So you're going to see this as you're going on with your notes. And again, you can actually put them into your graphing calculators, but as you're sketching, you have to use the intervals to figure out where within that graph the pieces of your functions lie. That's it for today's lesson. I'm super proud that I was doing something that I was so nervous about. Like, I waited till almost the end of 700 videos to do this one because I was so nervous about making a mistake. And that is silly, but even when someone is super confident in a content area, doesn't mean they're confident 100% of the time. We're human, we all have these moments. That's it for today's lesson, Math Marbles. Get to practice, and again, just try to shake it off and get more practice if you're feeling uncomfortable. It just means you're growing. I'll see you in the next one. Be well.